Another way to define a pharmacophore is through what is known as the geometric path to define pharmacophore. In this article from 2012, we see precisely that definition applied to a research work. It says synthesis and structure or relationship structure activity and model pharmacophore of pyrazole. Now, these pyrazole were designed as inhibitors of dipeptideptidase 4, which is an enzyme involved in diabetes. There it says antidiabetic. And look at the conclusion that they came. They say. So now you will say, but there is no common nucleus. There are geometric elements. Basically, we have two things there. We have very good distances, and second, we have atoms. For example, this here would be a hydrogen bridge emitter at that angle covering that sphere of space. Here a hydrogen bridge acceptor, here a ring or a hydrophobic center separated from another hydrophobic center. Then, as you can see, we have physical, chemical elements separated by distances, by angles. That is a geometric pharmacophore, and these numbers that very good are the distances in angstrom. We have the different distances, therefore how is this used? If you now want to propose something new, what will be the logic behind? To propose a new inhibitor on the basis of exactly very well that it meets these requirements that are similar to this, that it fits with this. Geometric pharmacophore example, if there it says, the two hydrophobic rings or two hydrophobics are favorable separated by approximately 10 angstrom, a strategy could be to have two separate rings. Then we could have this type of system. To see to draw it better, we are going to erase. Well, here, you could tell me about this here. I have them 1, 2, 3, 4, 5, 6, 7. It approaches a lot right now, where maybe we do not have a separation so appropriate. Probably here, because here there are only two atoms then. But this is feasible. To do this is a diazepine, or well, in reality, it is an epine. It is a dibenzosapina now. This system has the hydrogen bridge d'ador. But I think this distance does not respect it very well. It's very close to this, okay? Here it says 4 angstrom, maybe, with separated, because here, between these two and only one link, so maybe 2 to 3 angstroms of maximum distance from nucleus to nucleus. But it approaches the idea. Then already, with this in mind, one makes it stand out, obviously not more fine computational way. One can measure distances from this center to this, and we would have the possibility of creating something new, nothing more than seeing angles and links. Then I motivate you to chemically always be watching and trying to mentally design things, and that is the goal beyond resting only in a software. Well, let's see how. Then now on the other hand, it says types of procedures in the modification of a prototype. How on the other hand, we can modify a prototype, a leader, compound the first T. Strategy, the simplest, is nothing more than the structural simplification that consists of simplifying the molecule by eliminating fragments. Because you would want to modify a prototype. Well, the answer is when the structure is very complex. Example, a compound. The classic example, the case of morphine and its derivatives. We can simplify what we want not, because sometimes the activity is lost, and in sporadic cases more complex, the molecule is favorable, And that is what we look for the least for reasons of cost here is the elimination of each. One of the cycles there, we have the global image we have in the center, the molecule of morphine, and it came to the conclusion that what is in red is the pharmacophore now. How did this mean? Conclusion: eliminate things from the structure, creating synthesis molecules that are simpler. For example, here, the furan ring was erased. Here, the xenon cycle ring was erased here. All but the aromatic and the D were erased. What is this? To see this, for example, this quite simple. It is a benzene. It is an interconnected benzene. If you see it directly, this is how I have 1, 2, 3. Then it is 1, 2, 3. And here it is not true. Nitrogen, 2 cycles connected in that way, with different things. It is not true. Then, how is this nitrogen ring called? Very well, it is a perfect piperidine. Then we can see that the simplification is reaching its maximum level when we open the piperidine ring boot. If we eliminate the benzene, the activity is lost. Then, in that way, was an aromatic ring, a quaternary carbon, and including the quaternary carbon 3 distance atoms towards a protonable nitrogen atom. And that is why there is the pharmacophore marked in red in that way. Then we come to a structure question. And what was the pharmacophore? In the ergotaminic type, derivatives for the last one, also that we saw in the last class, when we had an ergotamine in a very complex structure. That was the ergotamine go over already. Exactly. And what was the pharmacophore? The ergotamine was superchemically complicated, talking about a complex molecule. But we came to this conclusion that the pharmacophore was an indole ring. And here, in position 3, 1, 2, and 3. And already with different R there, because it was the pharmacophore. What does this look like? Perfect, very. Well, this is a derivative very similar to serotonin. Serotonin has here, and in position 5, here it has a very good perfect. It has an alcohol, then this will have an effect on serotonin receptors. Well, here, I have another different pharmacophore, a quaternary carbon, and the protonable nitrogen. It is different, only abundant in pharmacophores, but the pharmacophore structure is different here, is the pharmacophore. Proposed then by simplification, we come to something simple. The structure can also be complexed, but that is rare for a reaction of the salter. We can place here an extra ring, and we have the ethylphine that is so powerful that it serves to sedate large wild animals, such as an elephant, for example. According to strategy, we could associate 2 molecules. We have as a second strategy the union, or the formation of a hybrid molecule, association of 2 molecules, and since we were talking about paracetamol, we already have the paracetamol molecule down there, the aspirin molecule, and the paracetamol. If it reaches the brain, and there is a theory, and there is paper about it, you can look for what is called the cannabinoid theory, that shows that there are paracetamol that covalently connect to membrane lipids, and that form of paracetamol would generate, let's say, a decrease in pain by acting on brain cannabinoid receptors. Apart from that, it is assumed that paracetamol could also be acting on brain cyclooxygenases in an isoform called COX-3. That is brain. There is a lot to study. Yet, therefore, that it reaches the brain. That is a hypothesis, the cannabinoid hypothesis. Now, what happens if it is like that? Because it could not be good. Sorry, I do not know if in an adult it could generate addiction. I already do not know it. But think that at the level of the nervous system, the cannabinoid system is a regulatory system. We have excitatory neurotransmitters, inhibitory neurotransmitters, but the complex than that. The cannabinoid system is like the medium regulating the function of other receptors. Then, touching that system with a xenobiotic with something external is probably not very good. Then it reaches the brain and produces several effects. Well, someone said since we can manage serious inflammatory processes, aspirin and paracetamol separately, why create a hybrid drug that is the union of both? Aspirin is an AINE, that is, aspirin has an anti-inflammatory effect. Paracetamol is not an NA. Paracetamol is an analgesic antifebrile. It does not have an anti-inflammatory effect. It is different. So how can we connect them? Well, here, the connection occurred through a feature reaction. What happened? There was the nucleophilic attack of the phenol to the acid, the feature, esterification of feature, which is nothing but an equivalent link to form this ester, and this molecule is a hybrid molecule, because if it is metabolized internally, exactly, by epithetic action or by action of these plasmatic aeroces when it breaks, paracetamol is going to be released and aspirin is going to be released. So it is a lot of sense to treat inflammation in adult people. Now about aspirin. A particular comment is also one of the drugs, one of the most sold pharmacies worldwide, and one of the applications apart from treating pain and inflammation is as an anti-aggregate plaque. That is, it is to prevent this being aggregated and thrombi are formed, which could be useful for heart attack, acute heart attack. Well, how do we prevent the plaques from being aggregated? We prevent the plaques from being aggregated in the following way. Cyclooxygenase 2 is a enzyme that degrades lipids, and cyclooxygenase 2 produces prostaglandins, and many prostaglandins perform normal functions in the body, beneficial functions for the body. But some produce pain, produce inflammation, and therefore we can block cyclooxygenase with aspirin. There are several isoforms. This is COX-only, this is COX-2. But that also, when blocking them, some or other mediators called prostacyclines are stopped, that are dilating glass of the arteries. Then if we do not have prostacyclines, the arteries are more likely to narrow. Then a long-term paradoxical effect can be due to prolonged use of aspirin. It should be for a while after suffering a heart attack, more than something in perpetuity. Exactly the minimum dose that is administered so far, and with aid that the problems are minimized quite a bit, is 81 milligrams, a slightly rare dose. They are all round values. Good for the case of aspirin is 81 milligrams. Of course, the aspirin of a child, the one of 100 milligrams. Well, here we have another hybrid. The first part already says diuretic action. We have a diuretic sulfonamide, the pharmacophore of a diuretic sulfonamide, that by direct alkylation generates this hybrid molecule. Direct alkylation of what? Well, this fragment down here is a fragment of a beta blocker agent. It is a derivative of a drug called pindodol. Remember these endings. That was a common international name. And let's see this. That is down here was an arrow. That is an aromatic system, oxypropanol, amine. That is the pharmacophore of a beta blocker agent. That is, it is an antagonist of beta adrenergic receptors. And therefore, if it is a beta adrenergic antagonist, that implies that this type of structures is going to reduce the work and a heart effort by reducing the blood pressure, because the beta receptors are the ones that tighten the heart. So, if you block them, it has a more relaxed pump and not a hypertension in the key body. That is why they are antihypertensive, prolonged defect through time but not fast, and the antihypertensive effect of a beta blocker takes a while to manifest. You know that one of the rarest adverse effects that there is the one that beta blockers produce. They have as an adverse effect to produce nightmares. And you have relatives who take beta, maybe they can corroborate that people say bad things at night. Something alters this in the brain because it also reaches the brain. In the brain, adrenergic receptors that we have may generate something good. Someone said, why don't we stick a diuretic in the amino group that helps eliminate urine and therefore reduce more blood hypertension? And why here? Because it is known that beta adrenergic receptors allow a voluminous group at the level of the amino. Therefore, the connection could not be anywhere. The beta adrenergic receptors, when this is linked to the beta adrenergic receptors, they have a space here that allows to connect something voluminous. Then this can act directly in the beta adrenergic receptors, and on this other part, it will also act on the nephron receptors to produce diuresis. We have two combined effects. Very interesting that they can tell me about the structure of this. Where? Very well exact. That carbon is chiral perfect, and we can look for some structure of this, so that you can see the importance of the chirality. We are going to capture screen. Yes. 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 Very good observation. The beta blockers have been consumed for specific situations of stress, for example, a student who has to pass the test and take the degree exam. There are students who have done it, have consumed propranolol to nervousness, the palpitations, the tremors of that moment of intense stress. And as they say, works okay, but it would be for something punctual. The other thing that works is to go up running stairs 10 minutes before. And I sign them now because once I did it and it worked. And I am going to show you the following here. We have the structure of the beta-1 energy receptor. Let's see if this is attached to something. This is not attached to anything. Then it is attached to antibody. But I want to show it attached to a drug. So let's go here. And here I think beta. For example, here we have beta-1 attached to carousel. Let's see the structure at the bottom here. In the PDB, you start looking for questions of all these molecules that are here, 1 to 2, 3, 4, 5. What is the drug? All that comes in the crystal, in the crystallized protein that has stuck. All that, which of those structures is the drug? What do you think? So looking at it quickly to the eye, beta-1. This is the receptor of the beta-1 energy at heart level. This produces an increase in contractility, is the one we want to block to reduce blood pressure. And we are going to hear what is 123. Very well, this one here that has the name cholesterol, and we already have a phospholipid here of membrane. Probably we have the drug. We have another glycol. Probably these parts of the citric acid solvents, that molecule, that is, let's say so, probably from the buffers with which the protein was created. Then that is why these other molecules are there. But look at the, let's see if I can maximize it. There it is. See how interesting arrow. That is, it is no longer true. Perfect. Propanolamine. And here the alkyl amine with a relatively voluminous group, not as exaggerated as the other. But here we can connect big things. Ask what charge does this have? Perfect. This is going to have charge +1. And this one here is going to be neutral because this is aromatic. Let's see then now. And the absolute configuration, that absolute configuration has this. This carbon there is a letter, of course. This carbon is the chiral. In fact, there it says it where T reaches it very well, but it is that it is not true that priority 1 would be for here and priority 3 for here. So it is that the proton goes backwards, and it is important. If then, look, we are going to give the interaction that should be reported here. Well, here sometimes it is not so easy to place this thing. You have to look for it here. One begins to explore. For example, within the ligands, we have to see which one it was, because it does not say drug. But it carbazole, it is click. And now we center the image. Perfect. And that is what interests me, that they observe very well. And look at the party here. It is already, this is a pie, as it is called, when they are left like this pipe. We have an interaction of pipe type that receives this. A phenylalanine down there says, phenylalanine 404 is numbered. And we have the pipe. I am going to rotate a little and see here two things. The ethanolamine part, that was the chiral part, because it is so important. Exact, here it is, that red that I am signaling with the cursor is the oxygen of the chiral hydroxyl. Then here is the chiral carbon. If it were, it would not do this. This to the other side, and therefore it would not do anything. This interaction would be lost. Then the affinity drops drastically. But here, look at a double interaction with this residue. Another thing that an aspartate says down there. That is, I have that the interaction is that proton is more than caught between those two oxygens. At the same time, they're at the same distance, the nitrogen that is being, and to see why it looks clear, look at the nitrogen. I'm going to see if I can move a little for a second. Yes, that's what I wanted to ask you. Look at. If you don't take it, clear it out there, look there, yes. Then we have that this nitrogen is doing an interaction for here with an asparagine. Then I have an interaction with an asparagine, with the oxygen of the asparagine. What does that mean? That the nitrogen, because the protons do not show the crystal the nitrogen. Proton's a proton for here, and what is this other interaction between the nitrogen with the aspartate? To be careful, of course, the carboxylate is negative, and this has a proton for here. But there is something else that does not show it to the image, that another interaction does the nitrogen with the oxygens. Exactly, very well, because we have that this nitrogen is positive and the oxygens are negative. So it is reinforced by Salini bridge that the image does not show it, and the rest now. You will say, and this fragment that we have here, look at this fragment that is an isopropyl. That isopropyl is alkylating the nitrogen, and it was like in a hole in a vessel that is here, because I told him that there is the receptor that allows you to connect voluminous. Here, let's connect the diuretic agent structure, because here the receptor allows, it has a lot of volume to be able to connect thousands of things and train hybrid drugs, background rationality in this case. And we return now then to the tip. And then we leave our hybrid drug aside. And now the most widely used strategy, called technically modulating replication, which consists of varying fragment by fragment. As it says here, it is a systematic replication of certain groups or structural portions, being the most used strategy, and we have several ways to vary fragments gradually. In a structure, such as by homology, by insertion, or suppression of regions, or aromatic rings, by opening or closing of rings, by insertion or erasing, finally by isosterism. So what are all those concepts we are going to simplify now? Because this is the simplest way to be able to modify a structure rationally when you see a new. First, let's remember these two concepts. One in a specific union, when a drug has an in a specific effect. What does that mean, do you remember? There is no specific receptor in which it acts now, but as for example, very well, the general anesthetics, for example, that alter the membrane and drugs such as surface antiseptics. Remember the paternal amines, and then they are all in a specific union agents that alter the cell membrane and that produces a chemical physical change with an answer that in this case could be a bactericidal activity. Long-chain alcohols, see how octanol, number of carbons, versus activity is the most toxic alcohol. There is for bacteria, but why not then they do not sell octanol in pharmacies instead of ethanol? Because octanol is much more expensive, and apart from that, octanol is not volatile. That is, if you apply it, it is like applying oil in your hands. It is not soluble in water. Then it's viable. Good observation. You know that in this case, the octanol is not soluble in water. So although one adds a little water, it is not going to be soluble. It is superlipophilic. Now remember that when we saw log PP, we said that it is the coefficient of partition of type octanol water, and then it is insoluble, and it simulates a membrane. Already perfect then, as we can see the biological activity with respect to the chain length. Continuous, more or less a Gauss-Bell. When the union is specific to lengthen or shorten chains, can have drastic consequences. A super short example, because obviously, if you lengthen or shorten chains, two fragments are going to have a different anchor to the receptor for the case of analgesic hymns. Like this one that is here, the essential requirement, 3 carbon. Already seeing that structure, the activity had that biological activity, has that compound. And that was short-term memory very well. And in general terms, this is a C. Narcotic agent is a powerful analgesic of the most powerful that there is, and that is why it is reserved only for cases of operations for cancer treatments when analgesia has to be extreme. And there is no problem in generating addiction, because this produces addiction, produces tolerance to what you know what tolerance means at the level of pharma, as I mean. Exactly, very well. Every day you have to administer a much higher dose. That is why heroin addicts endanger life. Every time they need more doses until they have a cardiac arrest. And then we have 3 carbons here. But what happens here next? If it is a requirement to have 3 carbons here, we lose the activity. Exactly, because on the other side, if it is scraped, then we can expand one side of the day cycle. And if we increase the 2, the activity is lost already, very well, perfect. These are the names below of these derivatives. Meperidine, that comes from a piperidine, and ethioheptacine means 7, and without that, they have nitrogen in. The second example I am going to show the structure is how the memory is in the medium term before going to eat empanadas and anticoco. You saw this, since it is this 2 quaternary amines and the chain that separates them. It was very simple, and look at the care more. And that is how they remember very well. They remember the little monkey, married I do not, approaching these parents I had to do to get rid of something. And then it turns out that that this is a ganglion blocker, or this is a nicotine agent, is a blocker of nicotine receptors, two quaternary amines separated by a chain. Well, what has been done is to explore the change in the length of the chain number of carbons versus biological activity. And there is an optimal range that more or less can reach 4 to 6, says the optimal here. But it can reach a maximum here as up to 10, and from there it begins to drop drastically because this becomes so long that only one side is linked and the other, there is no way for it to work if the chain is not long enough. It does not work either because we only have anchoring on one side, because the anchor was double exactly very well in the perfect nicotine channels. There was a site here and another site here, and how many acetyl columns had to be joined to very well, because the acetyl column is short. The acetyl column has this chemical structure, and how it is short, if 1 in 2, but these, as they are long with the molecule, they pace from one side to another, then that is why it has to have a length more or less within that range, so that the two can anchor there perfectly. Then, when you see a new structure like this, they are going to say a rational proposal to create a new series would be to modify chain lengths. When there is a chain example, it was tried to make a series of antihistamines. An antihistamine is to block the nasal secretions, so this antihistamine has an ethyl chain, and therefore homologation. Homologation means playing with one more carbon, one less carbon. Homologation means lengthening or cutting, putting or removing carbon. Then they did it, lengthened the chain, but a problem was lost. The activity and a new one was achieved. Nothing more than by modifying an atom in the structure, it stopped being anti-stamina and became anti-dopaminergic. This, what it does is block the dopamine receptors of 2. It is an antipsychotic. Therefore, a change in biological activity, so that you can conclude that there is a key interaction that the nitrogen atom makes when lengthening the chain. That key union was lost. But affinity was achieved in another very different receptor as dopamine receptors, and the antihistamine is at the peripheral level, but also at the level of the central nervous system. And why? Exactly as far as it is known, it is schizophrenic, and that is why distorted way very well. It has the medical beard. We hope that that is not a factor of human risk. And there is another picture of Bango with its distorted reality. Well, next example. Someone can say, teacher, and why, instead of lengthening or cutting, because we bet the chain ramifying a chain has super drastic consequences, often past high. When designing drugs, 1. If you ramify the hydrophobic interactions with the pill receptor, if it is that there are hydrophobic amino acids in the environment, then can increase the hydrophobic interactions. 2nd, when ramifying, it has been seen that the lipophilia does not always go up. Sometimes it goes down. You will see how that is sometimes this point. Look at this point, it is very delicate because we are incorporating one more atom that we refer with that the lipophilia goes down. I am going to insert a page that makes sense in the equality of carbon atoms. I explain, look, if you have this 2, 3, 4 to the 1, 2, 3, 4, 5, and this would be the pentane. That is lipophilic, and this other one has 1, 2, 3, 4, 5. It also has, and of course this is in fact called neopentane, and it also has 5. The two are C5H12. They are isomerous in the equality of amount of carbon, it asks, which is more soluble in water. The neopentane is more soluble in water. Very well then. This has less log P and has greater ramification. That is what we are referring to now. Question: why some explanation, something structural. Exactly. Exactly. It is much more difficult. The shape of the molecule is rounder, and therefore the spheres have fewer contact points than a flat surface. The first is longer, more flat, so to speak, more contact, more hydrophobicity. The second is more spherical, and that is why it has less log P. Then, when we say lipophilia goes down, we refer to their inequality of amount of carbon, because by general norm, if a molecule has more carbon than another, the logical thing is that the log P is that it is not confused when I review that. And third, if you ramify the chain, the molecule becomes more rigid, super important. This for selectivity effects, because the free rotation is restricted well. We have here a classic example. It says the mercapto propanoyl prolina question. Where is the prolina? That of mercapto is because it has sulfur. Very well, and the prolina is exactly. There is the prolina, it is hidden. There we have the prolina amino acid, that is acetylated on the nitrogen atom by this chain, and it is very structure arrived that later we will see in a section of how did they get to this type of structure with this chain length. And with that sulfur atom, this seems a little clear. Only that this is no longer amino acid this side here. But it could appear it could come from there, as for example, if here by a reductive deamination, not true at the enzymatic level, and well, it turns out that this, as an antihypertensive agent, is poor. That is what this does. This is an inhibitor of the angiotensin convertible enzyme. The angiotensin convertible enzyme. As the name says, it transforms the angiotensinogen in angiotensin 1, and in that way it is giving rise to a vasopressor agent. When angiotensin is released in the blood, angiotensin is released in the blood. When there is, for example, hypovolemia, when there is bleeding also, of course it is released to contract. The person manages to survive. And this is an example of irreducible complexity. How this system that controls the pressure is controlled not only by the angiotensin comes out of the kidneys, but also that is not from the kidneys, from the liver, but there is a previous stage that is controlled by the liver and by the lungs. That is, it is a whole system because the AKCA is expressed in the lungs. It is very interesting how one organ or another is interacting. And look, they put a single methyl group here in the chain on this side, and that comes from captopril. They sell it. Hypertensive patients always walk blister on the shirt because the captopril, what it does is quickly lowers blood pressure, is quite fast, and exists as a sub. If the person feels bad, it is placed under the tongue, it is absorbed, and the pressure is quite effective, and its effect is short. And this type of people, without any knowledge of the EKA, has super rare adverse effect. I do not know if you know the adverse effect of inhibiting the angiotensin convertible enzyme generates the suppression of another substance in the body called bradykinin, and that in turn generates as an adverse effect to produce dry who consume captopril or enalapril or lisinopril or fosinopril or any of those prills there. They have the key term, they have dry cough, not always, but when they have dry cough, they have to change the treatment because it is quite difficult to control. Imagine for the dry cough, it is not true that it will generate data because the methyl increased the activity because it fixes an active conformation that fixes the anti-type conformation. If we see eclipse, look at all this here. I am going to all this. We are going to call it R. This R. Because I say that this is anti. What do I mean by that? Sorry, no. But before that, I say opposite. It is not true that things are opposite. Exactly, very well, the substitutes of higher volume, the mercapto group or sulfhydryl, and all that be are. And then this is the projection of how these projections are called within. Well, the projections of Newman, and in the projection of Newman, you are seeing the molecule. You are eclipsing this link. This link is the rotable one the same from here, and of course, one the same from there. It eclipses already through this link. Then I have here frontal carbon. I have carbon there. Sorry, not the other. The here, there, if there, if we can eclipses the other also, but it would generate another projection there if then we have that here we would see methyl proton, and the R here is then methyl, whereas here methyl proton, and the R. And behind the mercapto, and the two protons, there is the mercapto and the two protons. The frontal carbon, the circle, represents the later carbon, is an obvious schematic representation. And it shows us that the substitutes of higher volume are separated with the largest dihedral angle. A dihedral angle of how many? 180 degrees, very well. And why is the active conformation fixed? Ask when having the methyl group, it is easier or more difficult than that road. More difficult because the methyl generates steric repulsion. With the sulfhydryl, then, here we have a steric contact. And this steric contact is what is called a Gocho-type conformation. A conformation in which these two are close, and it is like they are locked in the space, making that rotation looks restricted. So do not forget more when one ramifies a chain, the chain becomes much more rigid, and therefore, when it becomes more rigid, the chain, it is less rotable, that generates an anti-conformation, in this case, that is favorable for inhibition of the EKA of the converted enzyme of angiotensin. It generates a conformation. Everything is in place so much so that the sulfur, in fact, this sulfur that isn't just looking at the enzyme, that it is just looking at a sulfur atom that even forgives a zinc atom. Because it is important that what will happen between the sulfur and a zinc atom. Exactly, and that favors inhibition, because we have a grip by coordination between sulfur and zinc. There is a very good coordination, and that favors the. If instead of ramifying, we begin to incorporate extensive aromatic systems within the structure, that can happen. Increases the lipophilia. Already, very well. It will drastically increase the lipophilia. Second, they will increase very likely the type interactions and p-stacking. Perfect. And third, if it increases the p-stacking interactions, it will most likely increase the time of permanence in the receptor. If the permanence time in the receptor increases, what does that mean? That the compound is attached for more time to the receptor, and the compound is attached for more time to the receptor. Greater probability that it is a plug, that is to say, that it is an antagonist. Now it cannot first come to activate it. It could happen that it arrives, it activates stock, then the rest of the time, it is a blocker. There are many antagonists who do generate an initial activation, but from there the blocking, because they take a lot of time to get out of the receptor. Example, there is the structure of acetylcholine. Then someone said, we create a new derivative by changing the methyl group by aromatic rings. Then they took out this methyl group and connected this, and if the permanence time is in a place of regulation. Yes, of course, there could be that if the permanence time is a good question, if the time is. If the union occurs in a place of the osteric, of course, it is favored that the endogenous ligand act in a better way. If very well, there it would be a positive osteric modulator. If well, then this particular case, look at how the acetylcholine, the methyl group aromatic system, where we have that this is an aromatic ring, this one here, not because the one in the center is not perfect here, it does not have a proton here, then it is not aromatic. It is already angular, this system, and the hydrophobic contact in the alkylate part of the nitrogen atom must increase well. This system is also anchored to the muscarinic receptors. A muscarinic antagonist, see how it joins. And the propanthaline, although it is true, and it was, left to occupy as a drug. There are many drugs that are being deactualized. It was the base of origin to other drugs, such as this. Pargiferina. Exactly, I think it sounds more like the brand. Very well, the famous Viadeal. We go to the structure. Because the muscarinic receptors in the intestine favor motility, then with this we block that. See the structure of the famous Viadeal of the Pargiferina, the active component. Because Viadeal is the brand, and that is not the. Everyone has ever taken Viadeal in their lives. They should no longer sell it with dipirona. Because dipirona was banned in the United States because it is toxic. Imagine things that are happening with time. And then, sorry. It was one, if those long strips of plastic incredible puja here, well, it looks like this. Way, but the structure is understood. And what is the acetylcholine here? It is, look at the ester, the ethyl group, and the nitrogen, that in this case, you say it is not an ammonium, because this is going to protonate pH 7. And here is the strategy to aromatic ring, so that this is antagonistic instead of agonistic. There's the famous Pargiferina that you ingest when you consume the Viadeal, and the rest is an ether. This is not more than a lipophilic chain that is connected to it, a short chain, and of course, because there is a triple link, very well. And returning to the tip. I already explained it, so I am going to skip the explanation. P-stacking interactions, because that was in the previous tip. Finishing. Now, strategy, next opening or closing of rings. If you open a ring, the analog becomes more flexible, and that will increase the conformational freedom, and therefore simplify the structure, as we have already seen in the case of morphine. But if you close a ring, the compound becomes more rigid, and therefore we are going to have a fixed active conformation. Example of phenothiazine. I am going to show specific examples. Now question. Yes, sorry. Exactly, very well that you read my mind. and I am going to ask in which of the two cases have greater selectivity. Very well, perfect. Then here we have greater selectivity. In the union to the receptor's greater probability that it is active only in one receptors, the absolute selectivity does not exist. Now, I know that this gives me only one value in this receptor, because that is what the authors measured. In reality, the absolute selectivity does not always exist. The molecules have some other, like adverse effects. Something that does not have adverse effects is also a lie there. Something without adverse effect, everything has some type of effect. We see some characteristic cases of this. Look how interesting here. We have two molecules with the same biological activity, trimprasine and methyldiazine. Well, what are these? Are structures based on antipsychotics, of antagonists, of 2 to C. I'm going to count here. No, 1, 2, 3, counting from the nitrogen, and there 4 and the nitrogen, 1, 2, 3, 4, and the nitrogen it is pharmacophore, exactly the same. The only difference is that here on the side, the result of that asks why the lipophilia when cycling had a reduction. Because the insertion of this link makes the compound become a little less lipophilic. It is more spherical perfect where we have greater S-philicity. Now you will see it is despicable logarithmic scale. So it is not so despicable. Second says, cancel the sigma rotation of which link that is marking here with the arrow. That is, initially, this link is rotable, and now it is not rotable. 100% cancelled its movement. Another observation, this link is rotable here at the beginning with difficulties, because there is a methyl group, but now cycling becomes more drastically rigid, because we already have a complete structure, more heavy, with greater inertia. That makes it even more difficult, the rotation between carbon 2 and carbon 3, and finally, it says here, fix the orientation of the electronic pair. In other words, that I am going to ask you, which of the two derivatives is more protonable? And there is an analysis, well there, the open or the cycling. That is, technically which has greater, and look at the explanation. It is not so trivial. What happens is that and look, and that point comes from here. Remember that nitrogen at room temperature can easily experiment with the inversion of the electronic cloud. Remember something about that. That's why tertiary nitrogenes are not chiral, because the electronic cloud turns around. Through pyramidal structure is reversed very easily, and it is not that the molecule is turning. It is that already with an example of a bird and the umbrella that is being reversed. It is because the cloud that was up here now happens to be down. And therefore, if the three substitutes were different, one would say that maybe it was chiral. It is not because the electronic cloud moves very fast, interconverts one into another, but here this game is favored or limited to be cycled. Limited is much more difficult, and therefore the electronic pair remains fixed in space for longer, and therefore its protonation is easier because the electronic pair can now capture a proton with much greater ease, so it is moving from one side to the other. Then it is more protonable when it is cycled than when it is not cycled. And that is why I do not know if down here it says something about it, says that it slightly increases the more protonable, more spherical, more hydrosoluble. So all that for making a small cycle in the structure. Second example. Dopamine here is the dopamine structure. What happens if the dopamine we incorporate this long-term memory? Which molecule would be that? Without the H-dopamine, be careful. If it was not adrenaline, and how is the perfect? There is not true. It would have a proton menu, and it would have a methyl metabolically. All of those amines are related if metabolically there are biochemical roots. That from one can reach the other. Very interesting that I am going to erase. And well, this is the dopamine. And it turns out that we can fix a favorable bioactive conformation. We are going to see the Newman projection. The anticonformer has the best affinity for dopaminergic receptors. The anticonformer is to see them. That is, we are going to see this link. We are going to eclipse this link. There is -2 protons, and the question. And how do we fix this? By incorporating a cycle. We are going to cycle from this position to here. And that is achieved in this way. There we have the molecule 5.6, the hydroxy 2 amino tetraline that being cycled fixes the anticonformation between the amino group and the aromatic ring. There the strategy was a little more complex, and we had to see the molecule and think more or less in what part we could cycle, and then evaluate if that was feasible synthetically, and if it is not already a system so difficult to obtain. Well, the dopamine is involved, as we can see here. In pleasant experiences and addictive behaviors, on the other hand, the serotonin is like its small counterweight. If the dopamine involved in addictions, the serotonin stops that in some subpact way. If it does the opposite, for example, by inhibiting appetite, and also regulates the state of mind. And a final comment on the importance of the increase in selectivity. There are prototypes capable of interacting with many receptors, and today some of those are there is a strategy in medical chemistry that seems to go against the current that they call the multi-target drugs. Well, that makes sense when the effect that I'm going to have is synergistic. Not true, a multi-target effect to get a greater power in the final action. Exact with the paracetamol is obtained with more selective analogous frequencies when one restricts the conformation, and with fewer secondary effects when I want to solidify the molecule. Here is a punctual example. It says conversion of that antidepressant to an experimental of myoserine to the experimental agent of RL. Well, what was done here on the side is that myoserine also related to the mirtazapine are antidepressant molecules of polycyclic structure. The myoserine and the mirtazapine that is similar to this and our structures has been where we have two aromatic rings interconnected by another nitrogenated, and with some basic nitrogen in the structure like this one here, we have a total of 3 atoms from at least one of the aromatic rings. Example. Some are clear. What happens is that the inhibitors of the monoamine oxidase in general have a slightly smaller structure already as the cyproamine tranil. The inhibitors of the monoamine oxidase in general are a little smaller. And can have structures of this type. So this is an aromatic ring with a propane cycle. And an amino group is not the only pharmacophore possible. And the monoamine oxidase, as the name implies, it is an enzyme that degrades the endogenous catecholamines. Then, if with that enzyme, there will be more adrenaline in the body, more serotonin, and the moods improve. That is inhibiting the monoamine oxidase. Here is a direct effect with the myoserine that I am showing. In the diapositives, the effect, however, is direct. The effect of the myosin is direct on the receptors that raise the mood. So we have that the myosin is not an enzymatic inhibitor, but it does have these effects, antagonizes several receptors. Among them, for example, the 5-IT2, that is a type receptor, but in itself it is a receptor, and the 5-8A2 is a presynaptic type receptor, is a self-regulating presynaptic receptor. That is, if we antagonize it, we are blocking the stop signal within the neuron, and the neuron continues to release more serotonin. In adrenergic alpha-1 is also a self-regulating presynaptic release of noradrenaline. If we antagonize it, because these are the receptors that stop the release of the neurotransmitters, they are the presynaptics, not the postsynaptics, but the C. Problem is that they also antagonize the receptor's horn of histamine, and that is why brutal dream. Many of these antidepressants are consumed at night, and it is precisely because of adverse effect of the sleep that they produce already very intense another drug, clophenamine. Not true. They have consumed it, clophenamine, already. For what it is perfect, look at the two. Following, retain this idea in your minds. We already have this nitrogen here, aromatic rings, and we can connect here a pharmacophore in this way, there, and we have this distance. We have that pharmacophore triangle already for this antidepressant. But it is not true. Of course they come here. Well, I do not have all the structures. This is open, but it is familiar to him, two aromatic rings and triangles of approximable nitrogen. Nitrogen. Protonable. You see it then? There it is. That is why it has an antagonist effect. Home. If I erase that pyridine, very well, then ask, and the clophenamine is chiral. If not true in that carbon here, we have to go to the idea, because there are two different rings connected to it. And then now, they understand why this produces that brutal sleep. The similarity with their clophenamine is huge, only that it is more rigid. The other one was open. Well, how? Then we eliminate that. After studying how the receptor is linked, they came to this conclusion. We have to connect an extra ring in the structure then? As we can see here, extra ring. That is this union from here. How many rings are there in total? And then now 5 rings in a pentacyclic structure, and connect. That extra ring preserves the activity of the 5, preserves the alpha-1 antagonism, but eliminates the affinity of the clophenamine receptors. In their home receptors of this mind, for 2 reasons. The p-stacking interactions are lost, and polar interactions are lost because look. Sorry. And it is different. Look at this, because here we have that there is a dihedral angle that is different from the angle that we now have. It closed a little more when having the ring. I do not know if this computationally we could measure it, but the angle of these rings changed so that the p-stacking interactions with Hahn are no longer going to be so narrower, and the other thing has to do with that this has a pink color, an electronic pair. That is what is showing there towards here, is the electronic pair of the nitrogen. That is what there will be there at pH 7. There will not be an electronic pair. There will be what thing there is a proton is going to protonate, but now the angle at which that proton is projected is another. They see that it is similar, but it is not the same. Then the interaction is going to be more weak, because it moved from the place, said proton, that will be there at pH 7, and affinity was lost by the receptor Hahn. preserving the affinity in the other subtypes. So nothing more than adding a ring if you can make a drastic change in the affinity of this compound.